This first problem looks very familiar in the way it's worded, but there's a slight catch. So here we go. Given this function, write the equation of the line tangent to f prime of x at x equals -3. Oh, write the equation of a line tangent. Okay, I can do that. I can do that. What color should I use? Let's use black. You were thinking of a different color probably, and you're like, man, that's not what I wanted. All right, there we go. Well on our way. Well, our x value is -3, and our y value, what we're going to do is we're going to take -3 and we're going to plug it into, no we're not. Haha, things get tricky. We're going to plug -3 not into the function, but into the derivative. Well, wouldn't that find the slope? Sure, whatever. I want to write the equation of the line tangent to the derivative. So here we go. In just a minute, I'm going to need the slope of the derivative. Let me rephrase that. I need the slope of the slope. I need to take the derivative of the derivative. That's why we have higher order derivatives. You can take the derivative of a derivative of a derivative of a derivative. You can do this all day. But let's not. Fun as it would be. So f prime of x is equal to 2x squared plus 3x minus 1. Fantastic, great. So f prime of -3 is equal to 2 times -3 squared plus 3 times -3 minus 1. And that is going to give me 18 minus 9 minus 1. That's going to give me 8. So y minus 8. Now again, we're not plugging -3 into the function. We're writing the equation of the line tangent to f prime. So before I go any further, let me just kind of demonstrate what's happening here. I want to clear out my y equals. And we'll have 2/3 x to the third, I do that sometimes, plus 3/2 x squared minus x plus 4. And let's graph it. So I'm going to have this function that's probably not going to show up very well. Oh wow, that is kind of neat. That shows up pretty nicely. We're not writing the equation of the line tangent to the graph of f at x equals -3. We're not doing that there, okay? We're not doing that there at all. We're doing it on a different graph. And the graph we're going to be using, and we're not going to graph it, but the graph we're going to be using is the graph of the derivative. So let me show you a quick calculator trick. And you don't have to do what I'm doing, but I'm going to fix this to look a little bit more conventional. There we go. Now, people are less angry. I'm going to graph the derivative without finding the derivative. It's just a neat little trick, and so it's worth doing. So let's press Math. You know where this is going. I hope we're going to go to number 8 in deriv. So this is going to create the derivative at any given x value for our function. And this is really looking familiar, I'm sure. So alpha and trace, and we're going to press enter on y1. And at what x value? We don't want a specific x value. We want every x value. So at any given x value, as we move along this graph, we want it to calculate the derivative at that x value. So x equals x, as redundant as that sounds. And so we now have the original function, and it's a little bit slower when it does this, because it's calculating the derivative at each point that it plots. Takes it a while. So you have to make small talk while you wait on it. So how's it going? Hey, look. Derivative. This is the derivative right here. We didn't even have to find it. We could have just done it this way. But, you know, we know how to find it. So, good to know. Now you know. So what I'm really doing is finding the value. Let me rephrase that. I'm finding the equation of the line tangent to the red curve. Oops, I don't know if it's going to be able to work like that. It might just default to the blue curve. Anyway, we're finding the equation of the line tangent to the red curve at x equals -3, which is up here. Okay, which makes sense because there's your 8. Okay, enough small talk looking at graphs. We still haven't found the derivative, and that's the whole point of this lesson. We need to find the derivative of the derivative, and now we will take the derivative again. So I am not taking the derivative of this. I already did that. I'm going to take the derivative of this. 4x plus 3. Yay, great. Well, now I need to know the value of the second derivative at -3. 4 times -3 plus 3 is going to give me negative 12 plus 3, which gives me negative 9. So we're going to put a negative 9 right here, and you can leave it like that. I think that's perfectly fine. If you needed to make approximations, you should solve for y, but for now, that's fine.